Hello everyone. Today we will learn a new lecture, inter-VLAN communication. In last lecture, we talked about VLAN. We know that two devices in different VLAN cannot communicate with each other. They are not in the same broadcasting domain. Then how can they communicate? We should use inter-VLAN communication technique, which will be introduced in today's lecture. And today's lecture will be divided into 4 parts. In part 1, we will first talk about the background of inter-VLAN communication. We will learn why do we need this inter-VLAN communication. So this is the background. You can see that in real-world network deployment, actually different IP address segments are assigned to different VLANs. If multiple PCs in one VLAN can communicate directly with each other through the layer 2 devices, for example, the layer 2 switch, we call this communication as the layer 2 communication. However, if one PC in one VLAN want to communicate with another PC in another VLAN, then we cannot only use layer 2 devices. Instead, we need the layer 3 devices to support this kind of service. So this inter-VLAN communication actually belongs to the layer 3 communication, so that they require the layer 3 devices. And what is layer 3 devices? Actually, the router is a typical layer 3 device. The layer 3 switch and firewalls are also layer 3 devices. So here, if we need to communicate between this computer and this computer, then first the traffic should be transmitted through the layer 2 switch, and then layer 2 switch should forward the packet to the layer 3 router's interface, and then the router will send the packet to another interface, which can finally reach the another VLAN. Then the packet go through the switch and then finally to another VLAN, another PC. So this is the process of the inter-VLAN communication. We know that they cannot directly transmit it through the switch. They must go up to the layer 3 devices. Okay, so actually here the communication packets are routed by the layer 3 device. And how to enable the inter-VLAN communication? Actually, there are 3 different kinds. For first one is that we can use the router's physical interface. The router really have 2 interfaces connected with 2 using 2 cables to different interfaces in the switch, for example. So they have the physical interface. Another method is that in physical layer, we only have one interface, but we separate them into several sub-interfaces to implement the inter-VLAN communication. And the second method actually is to use the VLAN interface in the layer 3 switch to do the inter-VLAN communication. So here we will first introduce the physical interface inter-VLAN communication. Okay, so how to do the layer 3 communication using a router's physical interface? Actually, the network topology will be like this. We have 2 different VLANs, and we use the switch to connect it with the VLANs, the PCs in the VLANs. And then as all the packets should go up to the layer 3 device. So we assume that there is a router here. And in this router, we have 2 different physical interfaces. One is connected to the interface of the switch. Another one connected with another interface of the switch. So we can allocate the interface and VLAN into each interface. Now let's look at how to transmit the packet. Actually here, figure this interface as the access type, and we only allow the VLAN 10's packet to access. And then this outgoing interface are also the access type, which allow only VLAN 10. And this is connected to the interface 1 of the router. By configure the default gateway of this PC1 to be the interface 1 of the router, then the packets from PC1 will by default be forwarded by this switch to the interface of the router. So it has arrived here. And then the router can look up its routing table to check if this router needs to forward the packet destined to the PC2, which outgoing interface this should be forwarded to. Then it checked that, okay, this one should be forwarded from the interface 2. So the packet is transmitted here. And then when the packet arrived to the switch 1, they find that, okay, it is for the VLAN 20, and then they are transmitted out and until the PC2. The tag of the packet, actually, when the packet from this PC, they have no tag, right? And then when they go into the switch, they will have a tag. And when they go out from this interface, it still has no tag, right? And then because there's no tag, so they can be transmitted through this cable until the interface of the switch 1. And here and within the switch 1, they have the tag in it. And when they transmit out, the tag has been deleted again. So here, finally, when the PC2 receives the packet, it still has no tag here. So actually, the packet can transmit it correctly using the routing and forwarding of the layer 3 devices, the router 1. We use a router's physical interface to connect two different VLANs. However, in that example, actually we use two physical interfaces. Can we reduce the number of interfaces we need? Actually, the answer is yes. We can combine these two interfaces into one interface and combine this two interfaces into one interface. And we only use one cable to connect with the switch 1 and router 1. So the idea will be like this. Here in this interface, actually both VLAN 10 and VLAN 20's packet can go through. So this interface should be in the type of trunk. Okay. And then when the packet arrived to the router here, although they have one physical interface, but we need to separate it into two sub-interfaces. So you can think of that as two logical interfaces. So, and they have different sub-interface number. So one is .10, another is .20. And also different sub-interface will have different IP address here. Okay. And still we set this IP address as the default gateway of VLAN 10's packet, and this IP address as the default gateway of the VLAN 20's gateway. Okay. This is the configuration of this sub-interface transmission. Okay, and then let's look at how the packets are forwarded. So actually here you can see that the packets are transmitted from the VLAN 10 in the switch and then go to the outgoing interface, the trunk interface. And then they should be transmitted to the sub interface of the router. But here you can see that actually the packet here has no tag, and when it going out, they have the tag because they go through the VLAN 10. And then when they go into the trunk, they also have the tag here. Okay. Then actually in this interface here, actually it will be like this. This is the interface, but they include two sub-interfaces, and the packet out of one sub-interface should be forwarded to the other sub-interface. Okay. And through this sub-interface, the packet can be forwarded in the router 1 until arrive the destination. Here actually we have one problem here. So still look at this figure, because here in the router, they can only recognize the packet without tags. Okay, so we require the packet here has no tag. However, the packet go from the trunk has the tags on it. So actually before this sub interface forward the packet out, they should first delete the tags in the packet to terminate the tag. Okay, and then here when the packet are transmitted out, actually we need to add the tag again, so that when it go out of the trunk, they know that for the switch 1, they should forward the packet with tag 20 into the VLAN 20. If there is no tag here, the trunk doesn't know which VLAN they should forward the packet to. Okay, so here you can see that in this sub-interface, in the sub-interface 10, they need to delete the tag to terminate the tag. But here in the sub-interface 20, they need to add the tag to identify which VLAN the packet should forward it to. Okay, so how to implement this? Actually, we need to use the .1q termination command to do this. So the configuration of this sub-interface layer 3 forwarding actually is as shown in this figure. You can see that we first to configure the interface of the router 1. So we go into the sub-interface interface 1.10. And then when we go into this sub-interface, we need to first terminate the tag of the VLAN 10. Okay, so we use the .1q termination VID10 to terminate this VLANs to delete the tag from the packets. And we need to allocate the IP address to this sub-interface. And this MAC IP address actually needs to be set as the default gateway in the PC1. Okay. And next step is to enable the ARP broadcasting. By default, the ARP broadcast is not enabled in the sub-interface. In that case, all the broadcasting packets will not be forwarded out, and they will be discarded automatically. So to enable the sub-interface to forward the ARP broadcasting packets, we need to use this command, the ARP broadcast enable command, to let the sub-interface can successfully forward the ARP broadcasting packet out. And then for this sub-interface 2, similarly, we also need to use this command, which is the .1q termination VID20. So actually this command this command, they have two functions. One function is that when this sub-interface receive the packet from VLAN 10, they will delete the tag allow the packet into it and forward out. And another function is that when they want to send some packet out, they need to add the tag of VLAN 10 or VLAN 20 in the packet and then transmit out. So you can think of this sub-interface as the termination of the VLAN, a special VLAN. Okay, so, and we have bind this sub-interface with certain VLAN. And then we also allocate the IP address to the sub-interface and enable the ARP broadcasting. So in that case, we have binding these sub-interfaces with two different VLANs, and they can be successfully transmitted. So that is the method if we use the router's physical interface or we use the router's sub-interface to implement the inter-VLAN communication. Next, we will introduce another method, which is that we don't need a real router, a real device router. We can only use a layer 3 switch, and within the layer 3 switch, we use the VLAN interface. We can also implement the inter-VLAN communication by using this VLAN interface. So the configuration will be like this. So you can see that here we still have several PCs belong to different VLANs. However, we only have one physical device, which is the layer 3 switch. In layer 3 switch, actually they composed of two different modules. One is the layer 2 module, which is the switching module. You can think of this module as a layer 2 switch. And we have another module, which is the routing module, or which is the layer 3 module. You can think of that as the router, but actually we put the layer 3 router and layer 2 switch together into one device. Okay, so this is the physical configuration of this VLAN interface. And we need to connect the VLAN 10 in layer 2 switch with a VLAN interface. So first, in this layer 3 router, in this layer 3 module of the layer 3 switch, actually we need to set up two VLAN interface. One is VLAN interface 10, another is VLAN interface 20. And we also need to match this VLAN interface with the VLAN 10 and this interface with the VLAN 20. And these two interfaces actually they have a direct internal communication within this module. And in that case, we can see that we can forward the packet using this routing module. For example, if there is a packet coming in, then this should be forwarded to this virtual interface. And then because this virtual interface have a direct internal communication with this interface, so if they find that the next hop should be the outgoing interface should be this one, then they can be forward the packet to this interface by this internal communication. And then this one find that, okay, this packet is destined to a PC in this VLAN 20. So they will send the packet through the VLAN 20 and finally to this PC2. So the packet transmission is achieved. Okay, so to enable such communication, actually we need to configure the different modules in this layer 3 switch. So first, we need to configure the PC to give the default gateway to be this IP. Okay, and also we need to configure the default gateway of PC2 as this PC. So these two PC actually, these two IP actually is the IP address of VLAN interface 10 and VLAN interface 20. Okay, and then the key configuration actually is in the switch. So let's look at how to configure this VLAN interface in this switch. So first, we need to configure two VLANs here. Okay, and then we need to go into the interface 1. So this interface, to configure this interface. And this interface should work at the access type, right? Work at the access type. And the default VLAN ID should be 10 because they are connected with this VLAN 10. So this command. That's all for the interface 1's configuration. And then for the interface 2's configuration. So similarly, they should be in access type and the default VLAN ID is 20 to connect with the VLAN 20. Then let's configure the layer 3 module. So for layer 3 module, first we need to set up two VLAN interface. So here we use this command to set up, to create a VLAN interface. So we first create a VLAN interface 10, and then we allocate the IP address to the VLAN interface 10. So the IP address is as this one. And then similarly, we create a VLAN interface 20 and allocate the IP address. Okay, so that's all. How does this interface forward packet to this interface? Actually, we don't need to configure. They already connected with each other within this device. Okay, so after successfully configured the VLAN interface, actually we can analyze the packet forwarding process. So first, the PC sends a packet out. The packet is destined to PC2. And here, the source MAC actually is the MAC 1. And destination MAC should be the default gateway of this PC1's MAC address. So the destination should be MAC should be MAC 2, and the source IP is his own IP, and the destination IP should be the PC2's IP. Okay, so that's the packet transmitted from the PC1, and there is no tag in this packet. Then next, the packet, the VLAN 10 access interface will receive this packet, and they will add the 10 as the tag into the packet. So in this packet, actually they have already added the tag in it, and all the other things doesn't change. And then they arrive the VLAN interface 10. Next, when this VLAN 10 receives this packet, actually they will check the destination MAC address. They find that the destination MAC address is itself, so they will receive this packet, and then they will check the destination IP address. And they find that for that destination IP address, they should forward this packet to the interface 20. So they will rewrite the source MAC and destination MAC of the packet. So the source MAC should be rewrite as itself, the MAC 2, and the destination MAC address should be written as the still the MAC 2, and then send to the VLAN interface 20. And similarly, VLAN interface 20 will receive this packet and then to check whether it is for itself. Yes, it is for its, the MAC address, destination MAC address is for itself. So they should check it. And then they check the IP address to forward out. Here you need to be very careful that because this one is the termination of the so when they forward the packet, the tag has been deleted. And then this interface will forward out. And where does it forward out? To which outgoing interface they should forward? Because this IP address actually is belong the direct routing table of this VLAN interface 20, because this is directly communicate to this router, and this router is the default gateway of this IP address. So by looking at the direct routing entry, the VLAN interface 20 can know that they should forward the packet through this interface. And then it goes to the switch, and then the switch, by checking the MAC address table, they can know for the MAC address of PC2, they should forward through this interface. So that's all for the VLAN interface forwarding process. So you can see that the VLAN 10 and VLAN 20 in the switching module, actually they forward by checking with the MAC address. But the VLAN interface 10 and 20 in the routing module, they check the outgoing interface by looking at the IP address. So that's the key difference between the layer 2 switch and layer 3 switch. So these are three different type of inter-VLAN communication implementation. Now let's talk about the layer 3 communication process. So here, let's assume such a network topology. So still we have two different VLANs connected with a switch, and then they are connected. The switch 1 is connected to an aggregation switch, and then to a NAT or to a router, and within this router, they can provide the network address translation function to translate the interior IP to an outgoing internet public IP. And finally, through this router, they are connected to the internet, and there is a server also connected to the internet, and there is a packet from PC1 which want to communicate with the server. So let's describe the communication process from PC1 in VLAN 10 to the server 2.3.4.5 in the internet. This is the physical network topology of this network. If we look at the logical connection, actually you can see that within this access switch, actually they have two different VLANs, and this interface belongs to VLAN 10. This interface belongs to VLAN 20. It also has a trunk interface, which can transmit both packets from both VLANs. And then let's look at the logical connection of this aggregation switch. Actually, this aggregation switch is a layer 3 switch. They include two modules. So for the switching module, they have one interface connected with the switch 1. So this interface actually should be in the trunk type to support the traffic from both VLANs. And another interface is connected with the router. So if we configure this traffic as the VLAN 30, actually this should be an access port with VLAN 30 and communicate with the router. And above on the routing module, because here they should support three different VLANs. So in the routing module, they should have three different VLAN interfaces to match each of the VLANs. And then the default route on this switch 2 actually should be set to as this router to let all the traffic from this PCs to going out to the internet. Okay, this is the logical module of switch 2. And then let's look at the router. So here, the router actually first should be configured the static routes. The router need to know for the VLAN 10, they should forward through this switch 2. And for VLAN 20, they should also switch using this VLAN, using this switch 2. So they need to configure the VLAN 10 and VLAN 20 as the static routes. Okay, and then this router also have this NAT function. So NAT means network address translation. Actually, this technique is used to solve the shortage of IP address problem. So actually now you know that the IPv4 address has already been used out. So there is no new IPv4 address can be allocated all over the world. So people think of that maybe multiple hosts in the internet can share one public IP address, and they use a router with the NAT technology to implement this. So all the packets, when they go out, the outer internet will think of these packets from one same IP address. Okay, so actually to enable the internet PC using the private IP address to access the internet, this router's NAT can function as the configuration and the translation of this communication. So we configure the network address and port translation on the router 1. Okay. This is the logical connection. Now let's look at how a packet is forwarded until arrive the server. So first, this PC should send a packet to 2.3.4 to 0.5. But before they send this packet, they should send the packet to its gateway before determining that the destination IP address is not on its network segment. The packet transmits from PC1. Actually, the source MAC address should be MAC1. The destination MAC address should be the default gateway MAC address, so should be the MAC2. And the source IP is itself, the destination IP is the server, and because this is sent by the host, so there will be no VLAN tag. Next, this packet will arrive the switch. So the switch will look up the MAC address table to see for this MAC address 2, which outgoing interface they should forward. So by checking this MAC address table, they know that they should go from the 24. So they will send the packet through this interface. And then they will arrive the switch 2. And when they send out through this interface, actually because here the type of this interface is trunk, so they will not remove the tags. They will add the tag. In this interface, they will add the tag. And in this interface, it will not remove the tag. So the packet in this link actually should be with a VLAN tag 10 on it. Okay, and these 4 domains keep the same as the packet here. Okay, so that's the processing of switch 1. They just by checking the MAC address table to forwarding it. And then let's look at what does the switch 2 do. Actually, first, the switch 2 will look at the packet, and because they find that the destination MAC address is itself, so they will forward the packet to the routing module, and then at the routing module, they will check the routing table. Here you can see that in this routing table, for all the packets, the next hop should be this IP address. It means the next hop should be the interface, this interface of the router 1. So all the packet will be forwarded to this hop, right? So actually, just now that packet should also forward it to this interface, and they should go through this outbound interface, VLAN interface 20. So that is done by the router routing module in this switch 3, layer 3 switch. And then when they go out through this VLAN interface 30, it will go to the VLAN interface 30's module in the switch module. And then this VLAN interface 30 will check whether the packet can be transmitted out. So here you can see that this is the outgoing packet. So first, the switch 2 will find the MAC address corresponding to this one, right, to the next hop. So they find the MAC address is MAC 3. So they will change the destination MAC to be MAC 3 and the source MAC to be itself. And this source IP destination IP will keep the same and keep unchanged. And how about for VLAN tag? Let's analyze the process. So actually here, switch 2, actually they have two modules, right? So here is the routing module. Here is the switch module. And in the routing module, they have three VLAN interfaces. And in this switch module, they have two interfaces. One is the trunk interface for both VLAN 10 and VLAN 20, and another is the access interface for VLAN 30, right? So here, actually, when the packet arrived to this VLAN 10, so this is VLAN 10, this is 20, this is 30, right? So the packet go from the trunk to this VLAN 10. Actually, they have the tag 10 here, and then by going to this VLAN interface, they will remove the tag 10, and then they will send to the 30, and then when the 30 go into this interface, they will have the tag 30, right? But this is an access interface. So when the access interface transmits the packet out, actually the 30's tag has been removed. So there is no tag any longer, right? So here you can see that the VLAN tag actually has already been removed. But within this router, they will indicate which VLAN this packet should be forwarded to. Okay, you can see that the packet transmitted out from the switch 2 actually will have no VLAN tag, and the source MAC address and destination MAC address has already been changed. Now let's look at what does this router do. Actually, in this router, first they need to check for the destination MAC address, where should the packet be forwarded. And when they check its routing table, they find that okay, so for this IP address, they should go from this interface to the to the internet, and then they will send out a packet out. And because here they will have this NAT, they will do the network address translation. So within this NAT, all the IP address actually is the interior IP address, the IP address in the intranet. But when it go out, the IP address should be translated into the public address. So you can see that the source IP actually has already been changed from the internal IP to be the public IP, and the destination IP is still this one. Okay, so these are the things done by this router. So this router should first check the outgoing interface and then do the network address translation. So finally, this packet can be arrived to the server. Okay, so that's all for the layer 3 communication method. Okay, so until now, we can summarize the content we talked in this lecture. Actually, in this lecture, we described 3 methods for implementing inter-VLAN communication. One is that we can go through the physical interface. By using this method, we need 2 physical interfaces in the router to connect with 2 separate interfaces in the switch. And then another one is we can communicate through sub-interfaces. So by using this method, we only need one interface, one physical interface. But logically, we will separate this physical interface into 2 sub-interfaces. And next one is the VLAN interface. So this VLAN interface actually is in the layer 3 switch instead of the layer 3 router here. So we can only use the layer 3 switch to do the inter-VLAN communication by configure several VLAN interfaces connected with different VLANs. That's okay. Okay, so these are 3 different implementation methods. And we also elaborate the whole process of the layer 3 communication. We analyze for every device what they should do and how the packet header changes during the communication. Okay, so that's all for the content in this lecture. So finally, let's do a comprehensive comparison between layer 2 and layer 3 interface. So until now, actually, we have already learned layer 2 device, layer 3 device, layer 2 interface, layer 3 interface, and both of them actually forward the packet. However, they have several key differences. So let's analyze their fundamental difference. So first, for layer 2 interface, actually, they only forward by checking the MAC address, right? So they will do nothing to the IP address. So the IP address cannot be configured for layer 2 interface. They have no IP address, okay? But for layer 3 interface, for each router or for each layer interface for the layer 3 device, they can be configured with an IP address. Only if they have an IP address, we can think of them as the layer 3 interface. Okay. And next one, the layer 2 interface doesn't have MAC address. So they just connect the interface with the PCs and routers, but the interface itself has no MAC address. But layer 3 interface itself will have a MAC address because this interface may become the destination MAC or source MAC of a packet. Okay. And next one, after the layer 2 interface receive the data frame, actually they will check for the MAC address table. They will check the corresponding relationship between the MAC address and the outgoing interface. So they will only search the MAC address table. If it's matched, then they will forward through the corresponding interface. If no matching entry is found, the packet will be flooded out through all the outgoing interfaces. So these are the process, the operation mechanism of layer 2 interface. However, for layer 3 interface, when they receive a data frame, if the MAC address of the data frame is the same as its local MAC address, this means the packet is for itself. And then it will decapsulate the data frame and look up the destination IP address in the routing table. So they will check first the IP address and second in the routing table. That's different from this one, okay? And if it is found, they will forward through the corresponding interface. But if no matching route is found, it will not flood it out. It will not broadcast it out. Instead, it will discard the packet. So this is another difference between layer 2 interface. So here, about the operation, actually there are 3 different points. One is that this one check MAC address table. This one check the routing table. Second, this one search for the MAC address. This one search for the IP address. Okay, and the third one, this one, if it is not found, it will broadcast, it will flooding. But for this one, if it doesn't found, there is an error. It will simply discard the packet. Okay, and next, let's look at the interface. So actually here, a physical interface on layer 2 switch actually is a typical layer 2 interface. The physical interface of most layer 3 switch actually can work on both layer 2 and layer 3. Okay. Look at the interface on switch. Actually, for the layer 2 switch, all the interface is layer 2 interface. And for the layer 3 interface, by default, all the interface will be configured as the layer 2 interface. Although they can work on layer 3, okay, by default, they work on the layer 2. And for router, actually, all the interface on the router is the layer 3 interface. And besides the physical layer 3 interface, actually we can have the logical layer 3 interface, which is the VLAN interface, which can be configured on the layer 3 switch. Okay, so and also we can configure the sub interface. That's also the layer 3 interface. Okay, so both VLAN interface and sub interface are logical layer 3 interface. Okay, and finally, the layer 2 interface and layer 3 interface will divide the network into different domains. So for layer 2 interface, they can connect all the hosts and devices together. So they will not divide the network into the isolated broadcasting domain. Instead, they will flood all the packets they received. But however, if the packet goes through a layer 3 interface, actually there has already been isolated. So layer 3 interface actually isolate the broadcast domain. The networks. So if we delete all the layer 3 interface or the layer 3 devices, then all the other connected network can be a broadcasting domain. So the layer 3 interface actually will directly terminate the broadcasting. Okay, so they can prevent from the broadcasting storm all over the network. Okay, so that's all the comparison between layer 2 and layer 3 interface. They are very similar because they can both forward, but they have fundamental differences. You need to very careful about it.